Hello everyone, welcome to lecture 2 of CIN635, and in this week's lecture we will be looking at mobile computing architecture. First of all, we'll start with the history of internet. So the history of internet generally is divided into three portions: history of internet 1, 2 and 3. So we look at what things are covered in history of internet 1. So Advanced Research Project Agency, or ARPA. Now, following the successful launch of Sputnik in 1957 by the Russians, the United States of America felt that the need for research in certain focus areas were necessary. Therefore, ARPA was formed to fund science and technology projects and position USA as a leader in technology. By the way, Sputnik is basically a computerized system that was generally used during the wars by the Russians. Packet switching. Packet switching in early 60s, Leonard Kleinrock developed the basic principles of packet switching at MIT. What is packet switching? Packet switching is the transfer of small pieces of data across various networks. These data chunks or packets allow for faster, more efficient data transfer. Often, when a user sends a file across a network, it gets transferred in smaller data packets, not in one solid piece. RAND Corporation reports. In the early 60s, Paul Barron, in a series of RAND Corporation reports, recommended several ways to accomplish packet switch network. First, computer network. In 1965, working with Thomas Merrill, Lawrence Roberts connected the TX2 computer in Massachusetts to the Q32 in California. So these two are in different geographical spots within the United States of America. So Roberts connected TX2 computer in Massachusetts to Q32 in California with a low-speed dial-up telephone line, creating the first computer network. The TX2 computers were computing devices used back in the 1950s to the 1960s. History of Internet 2, electronic mail. In 1971, Ray Tomlinson at BBN wrote the software to send and read simple electronic mail. BBN is currently renamed as Raytheon BBN Technologies. It is an American research and development company. ARPANET. In October 1972, demonstration of the ARPANET was done at the International Computer Communication Conference, ICCC. This was the first public demonstration of this new network technology to the public. It was also in 1972 that the initial hot application, electronic mail, was introduced to the world. NSFNet. In 1962, the US NSF initiated the development of the NSFNet, which provided a backbone communication service for the internet. The National Science Foundation Network, which is also called as NSFNet, was a program of coordinated, evolving projects sponsored by the National Science Foundation from 1985 to 1995 to promote advanced research and education networking in the United States. The internet. In Europe, major international backbones such as NodeNet and other provided connectivity to a large number of networks. Internet slowly evolved as the universal network of networks, which connects almost every data networks of the world with a reach spread over the whole earth. Internet, the history of it, part 3, Internet officially defined. On October 24th, 1995, the FNC unanimously passed a resolution to officially define the term Internet. According to this resolution, the definition of Internet is: Internet refers to the global information system that logically linked together by a globally unique address space based on the IP or subsequent extensions. The Internet is able to support communications using the TCP/IP suite or its subsequent extensions. Moreover, the Internet provides, uses, or makes accessible, either publicly or privately, high-level service layered on the communications and related infrastructure described herein. Next is MEMEX. Now, V. Bush, through his July 1945 essay, which is called As We May Think, described a theoretical machine called a MEMEX, which is able to enhance human memory by allowing the user to store and retrieve documents linked by associations. Mouse invented. During 1960s, D. Engelbart prototyped an online system, NLS, that does hypertext browsing, editing, etc. He invents the mouse for this purpose. The World Wide Web. In 1991, Tim Berners-Lee invented hypertext markup language, which we call it in simple terms HTML, and he also went around developing Hypertext Transfer Protocol, HTTP. Tim wrote a client program and named it as World Wide Web, which finally became WWW and became almost synonymous with the term Internet. Internet. 3 basic types of content: audio, video, and text. Some can tolerate little delay in delivery, packet switch networks like Internet, whereas some cannot, telecommunication or circuit switch networks. There are 3 main types of segments of any network. Core. It is the backbone of network and looks at the traffic from the stream of bits point of view. Core, just as the name signifies, is the backbone of the network. The primary function is to deliver traffic efficiently at the least cost. Long-distance operators and backbone operators own core networks. Deals with transmission media and transfer points. Edge, the next segment, responsible for the distribution of traffic and looks at the traffic from the service point of view. Edge is managed and owned by ISPs and local switches or exchanges. ISP, by the way, stands for Internet Service Provider, example, Vodafone Fiji. It is responsible for the distribution of traffic. The next segment is access, deals with the last mile of transmission. Access is the endpoint or the device by which the service will be accessed, either through a wireline or the wireless. From a mobile computing point of view, mostly it is through wireless. Architecture of mobile computing. The 3-tier architecture contains the user interface or the presentation tier, the process management or the application tier, and the data management tier. Mobile computing architecture refers to the definition of multiple layers between user application interfaces, devices, and network hardware. A well-defined architecture is necessary for systematic calculations and access to data and software objects. By examining the slides in front of you, there are three tiers in the architecture of mobile computing. These include presentation tier, application tier, and data tier. Each tier is distributed to a different place or places in a network. These tiers do not necessarily correspond to physical locations on various computers on a network, but rather to logical layers of the application. Let's examine these tiers way more carefully. Presentation tier. It is responsible for presenting the information to the end user. Run on the client device and offer all the user interfaces, includes web browsers, and client programs. The presentation tier presents data to the users and optionally permits data manipulation and data entry. Also, this tier requires the data from the business layer. This layer is accomplished through the use of dynamic HTML and client-side data sources and data cursors. Application tier does the transcoding of data for appropriate rendering in the presentation layer. Can include technology like CGIS, Java, JSP, .NET services, PHP deployed in products like Apache, WebSphere, and WebLogic. Handles functions related to middleware. The application layer is the business logic that acts as a server for client requests from workstations. It acts according to business rules and fetches for instance data through the data layer. In turn, it determines what data is needed and where it is located, and acts as a client in relation to a third tier of programming that might be located on a local or mainframe computer. Because these middle tier components are not tied to a specific client, they can be used by all applications and can be moved to different locations as response time and other rules require. It is independent of presentation and data management. We've also noted that the application tier handles functions related to middleware. What is middleware? Middleware is a layer of software sitting between the operating system and the user-facing software, that is the application software. There are many different types of middlewares. Some examples may be message-oriented middleware, transaction processing middleware, communication middleware, distributed objects and components middleware, transcoding middleware, web services, etc. Let's have a look at these middleware. Like defined earlier, middleware are softwares that provides a link between separate software applications. It is a layer that lies between the operating systems and the applications. Before we look at message-oriented middleware, let's have a look at some of the uses of middleware. So the middleware provides interaction with another service or application. It filters data to make them friendly usable, make an application independent from network services. It makes an application reliable and always available. Moreover, it adds complementary attributes like semantics. Message-oriented middleware loosely connects different applications through asynchronous exchange of messages. It works independent of platform or processor configuration, generally asynchronous and peer-to-peer. Message-oriented middleware supports the receiving and sending of messages over distributed applications, enables applications to be dispersed over various platforms. It makes the process of creating software applications across many operating systems. It makes network protocols less complicated. Moreover, it holds many advantages over middleware alternatives and is one of the most widely used types of middleware. Now, we have learned right at the very last point in the lecture slide that generally it is asynchronous. The word asynchronous means not existing or occurring at the same time. Moreover, it also says generally asynchronous and peer-to-peer. Now, peer-to-peer is denoting or relating to networks in which each computer can act as a server for others, allowing shared access to files and peripherals without the need for a central server. Transaction processing middleware provides tools and environment for developing transaction-based distributed applications, capable of providing services to thousands of clients in a distributed client-server environment, independent of database architecture. This type of middleware includes applications like transaction processing monitors. It also encompasses web application servers. These type of middleware are becoming more and more common these days. Communication middleware. It is used to connect one application to another. Quite useful in the telecommunications world. Uses mediation server to automate the telnet protocol to communicate to nodes in the network. Example, using telnet to connect one application to another. Communications middleware is basically a computer software that enables two otherwise separate software components, processes, and/or applications to exchange information, either within one device or between multiple devices. Sometimes, and moreover often, communication middleware is often referred to as IPC or inter-process communications. Object-oriented middleware. Object-oriented middleware is also known as an object request broker. It provides the facility to send objects and request services via an object-oriented system. In short, it manages communication between objects in a network or between a client-server exchange. Remote procedure call or RPC monitor. It provides the facility to call procedures on remote systems and is used to perform synchronous or asynchronous interactions between applications or systems. It is usually utilized within a software application. RPC is a protocol that one program can use to request a service from a program located in another computer on a network without having to understand the network's details. Database middleware. It provides direct access to databases and direct interaction with databases. There are many database gateways and connectivity options that you simply have to see what will work best for your necessary solution. This is the most general and commonly known type of middleware. Database middleware often includes SQL database software. It simplifies access to and interaction with backend databases. Embedded middleware. This type of middleware allows the facility of communication and integration of services with an interface of software or firmware. It acts as a liaison between embedded applications and the real-time operating system. Embedded middleware, a standardized object-oriented application interface for supporting distribution of network embedded applications, would solve the networking problems of communication applications. Firms have a demand for an embedded middleware framework that would enable building up embedded network systems. Content-centric middleware. This type of middleware allows you to abstract specific content without worry of how it is obtained. This is done through a simple provide or consume abstraction. It is similar to publish or subscribe middleware, which is another type of this software that is often used as a part of web-based applications. Content-centric middleware makes it possible for developers to extract some piece of content without having to know how the system obtains the content. Web services. It provides a standard means of communication and information exchange among different software applications. Public interfaces and bindings are defined using XML in web services. Standards for service request and service provider. Service requester find and discover the description of services. Service provider publish the description of services provides. The term web service is either a service offered by an electronic device to another electronic device, communicating with each other via the World Wide Web, or a server running on a computer device, listening for requests as a particular port over a network, and serving web documents. Data tier. Used to store data needed by the application and acts as a repository for both temporary and permanent data. Can use XML for interoperability of data with other systems and data sources. Might incorporate the use of database middleware. Database middleware, like we had a look at it in the previous slides, it interfaces application programs and the database. It helps business logic run independent and transparent from database technology and database vendor. Data access layer, generally it is a third tier of the three-tier systems and is made up of databases that provides data to all the other two layers. This is the actual database management system access layer. It avoids dependencies on the storage mechanism and allows for updates or changes without the application tier clients being affected by or even being aware of the change. So this concludes your lecture slides for lecture 2. Now in this lecture, we had looked at few important things. First of all, we had looked at what is mobile computing architecture, and we had a good and a keen look at the three labels of the history of the internet, that is Internet 1, Internet 2, and Internet 3. Moreover, we went around describing what is an internet. And finally, we looked at the architecture of mobile computing, which comprises of 3 tiers: the presentation tier, application tier, and data tier. Thank you.